Professor, I just read something incredible about gut bacteria and aging. Is it true that microbes from a young mouse can actually make an old mouse healthier?
It sounds wild, but it's true and very exciting. Our gut microbiome, the trillions of bacteria and other microbes living in our intestines, might hold secrets to aging. Even though they're tiny, these microbes have a mighty impact on our health. In fact, the composition and function of our gut bugs change as we get older, and those changes are linked to our health and lifespan. Some scientists even call the gut microbiome a forgotten organ, because it plays such a crucial role in our body's systems. Imagine the gut as a bustling city of microbes that helps run our body. As we age, some neighborhoods in this city change or deteriorate, which can affect the whole metropolis, our body.
So if the city of gut microbes changes with age and maybe causes problems, what can we do? Rebuild the city with younger microbes.
Exactly. The idea is something called Fecal Microbiota Transfer, or FMT. It's essentially a gut microbiome transplant, taking the microbiota from a healthy donor's feces and transferring it to another individual's gut. It's like reseeding a garden or rebooting the city's population with new, beneficial inhabitants. This is already used in medicine for certain infections like C. diff infections to restore a healthy microbial community. The question researchers are asking now is, can FMT from a young individual to an older one rejuvenate the older one's health, maybe even slow down aspects of aging?
FMT. I've heard of that being used for gut infections, but using it for aging is a new concept to me. How would that work?
Think of it this way. If aging causes the gut's microbial city to fall into disrepair, with beneficial bacteria dwindling and harmful ones creeping in, then transferring young microbiota could be like urban renewal. We introduce a youthful mix of microbes to restore order. There have been some promising hints from early experiments. For example, initial studies showed that giving germ-free mice raised with no gut microbes at all, the microbiota of young animals could extend lifespan or improve brain function. One 2022 study by Parker et al. Even found that an FMT from young to old mice could reverse some signs of aging in the gut, eyes, and brain. It was like the young microbes sent anti-aging signals throughout the body. On the flip side, when young mice received gut microbes from old mice, they showed signs of inflammation in the brain and eyes, highlighting how an aged microbiome can promote aging processes.
Wow, so the gut microbiome doesn't just affect the gut, it can influence the brain and even eyes. That's impressive.
Absolutely. The gut might be in your belly, but it has far-reaching effects. Microbes in the gut communicate with the immune system, produce metabolites that travel in the blood, and even interact with the nervous system, often called the gut-brain axis. If the gut barrier or the intestinal lining gets leaky with age, bacterial products can slip into the bloodstream, causing the immune system to be chronically activated, a phenomenon known as inflammaging, which is a blend of inflammation and aging. It's like the city's walls are crumbling and invaders are leaking out, triggering an endless alarm in the body. This chronic inflammation is linked to many age-related diseases. By rejuvenating the gut microbiome, we aim to repair the walls and calm the immune system. Think of the microbiome as an orchestra conducting the immune and metabolic harmony of the body. When it's out of tune, you get chaos, disease, and inflammation. But if we retune it with healthy young microbes, the whole symphony can play in harmony again. Okay, time for a quick science check-in. You're doing great so far. Clearly someone who enjoys learning about the cutting edge of biology. Which of these is a reason scientists are exploring young-to-old fecal microbiota transfer, FMT? Drop your answer in the comments and let us know what surprised you most about the gut microbiome so far. And hey, thanks for being the kind of person who's curious enough to explore this topic. We love having you here.
That makes sense. Let's talk about the new study I read about, the one where they repeatedly transferred young mouse microbiota into old mice. How did they set that up?
This new study is fascinating because it tried a more realistic and long-term approach. Previously, many experiments did just a one-time transplant and often used germ-free mice. But germ-free mice have unusual physiology, like weakened immune systems and trouble digesting food, so results there might not translate to normal animals or humans. The researchers, led by Felix Sommer and colleagues, took a different approach. They used normal older mice with their own microbiome and gave them repeated FMTs from young mice throughout their life. Procedure: every 8 weeks, the older mice got a fresh dose of gut microbiota from young 8-week-old donor mice. Before each transfer, the old mice were given a mild antibiotic treatment to wipe out some of their existing gut bacteria, basically clearing the field so the young microbes could establish better. This is like clearing out the old city infrastructure before building the new one. Using antibiotics has downsides, though. There's a risk of antibiotic resistance, and it might have its own effects on aging. The scientists were careful to note that. Control group. It's important to have a comparison, so the control old mice went through the same procedure but received microbiota from mice of the same age as themselves, essentially an old-to-old transfer. That way, any differences could be attributed to the youthfulness of the microbiome, not just the transplant process.
So they kept doing these microbiota transplants repeatedly throughout the mice's life.
Yes, they started in midlife for the mice and kept going regularly. They monitored the mice all the way to 120 weeks of age, which is pretty old for a mouse. This long-term, repeated approach is why the study is getting attention. It's more like a persistent therapy, not a one-off. They jokingly call it microbiome rejuvenation therapy because you're constantly refreshing the gut with young microbes.
I bet they were hoping to see the treated mice live longer. Did it work? Did the mice actually live longer with all these treatments?
They saw a trend toward longer lifespan, but it wasn't a slam dunk statistically. By week 120, a lot of the control mice, the old-to-old transfers, started dying off quickly, whereas more of the young transplant mice were still alive. It looked like the treated mice were living longer, but the sample size at the end became small. Unfortunately, a number of mice in both groups died earlier in the study due to an unrelated issue. They had some injuries from the oral gavage, the process of feeding the mice for the transplant. Those accidental deaths introduced a lot of variability. With fewer mice left, the survival difference wasn't statistically significant. In fact, the p-value was around 0.067, meaning it narrowly missed the usual cutoff for significance. The researchers think if they optimize the procedure, for example, a gentler way to do the transplant without force feeding, they might get a clearer result in the future. So no definitive lifespan extension was proven yet, but the data hinted at a possible benefit if they refine the method.
Got it. So lifespan wasn't clearly extended because of those complications. What about other aspects of aging? Did the treated old mice feel younger in other ways?
Yes, this is where the results were really encouraging. The mice that received the young microbiome showed several signs of improved health span, health during aging, even if lifespan wasn't dramatically changed. Here are some key outcomes from the study intestinal barrier improvement. The treated old mice had a stronger gut barrier. Normally, with age, the gut can become leaky, but the young microbiota transfers reduced leakage of bacterial products into the blood, indicating the intestinal lining was more intact. You can picture an animation here, an old gut with cracks in its wall versus a post-transplant gut where those cracks have been sealed. This means fewer unwanted toxins getting into the body to cause trouble. Reduced inflammation. Because less bacterial antigen was leaking out, the immune system in the treated mice was less overactivated. They actually measured an inflammatory score related to gene expression of inflammatory markers in various immune cells, and it was lower in the mice with young microbiomes. In other words, the chronic age-related inflammation, known as inflammaging, was reduced. This aligns with the idea that fixing the gut barrier calms down systemic inflammation. One could imagine a chart of inflammatory markers in blood or tissues, showing lower levels in the young FMT group compared to controls. Metabolic and molecular rejuvenation. The gut microbiome of the treated mice started to resemble that of a young mouse. In fact, the microbial community composition in those mice shifted closer to the youthful profile. This wasn't just a cosmetic change. The metabolic functions of the microbiome were rejuvenated too, meaning the collection of microbes was producing beneficial substances like a young microbiome would. The authors noted that this rejuvenated microbiome provided beneficial metabolic functions to the host and thereby may contribute to delaying physiological processes associated with aging. So the old mice were essentially getting the metabolic help of a young gut again. For example, they found an increase in a bacterium called Akkermansia in the treated mice. Akkermansia is often considered a good bug associated with improved metabolic health and even longevity in mice. In fact, a 2019 study showed that just giving Akkermansia to progeroid or rapid-aging mice improved their health and lifespan, which might explain why having more of it helped these mice. Interestingly, the treated mice had a drop in some lactobacillus species, usually thought of as beneficial probiotics, which the researchers found puzzling. They suspect maybe not all lactobacillus are equal, and specific strains matter. It's a reminder that the microbiome is complex. Better physical function. The researchers tested the mice for physical performance. They didn't see changes in everything. For instance, glucose metabolism or blood sugar control was similar in both groups, and muscle grip strength didn't differ much. But notably, the mice with young microbiota showed improved coordination. This was measured by a coordination test. Imagine something like a balance or walking test for mice. And the treated mice performed better than untreated old mice. It's as if their neuromuscular system was a bit sprier, potentially thanks to reduced inflammation or other factors. A visual here might be a side-by-side of an old mouse on a little balance beam versus a treated mouse showing the treated one steady and the control wobbly, or a simple bar graph of coordination test scores with the young FMT group scoring higher. You're still with us? Amazing! You're officially in Science Explorer territory. Let's test your growing microbiome mastery with a tougher one. Why might the bacterium Akkermansia be considered important in microbiome-based aging research? Share your answer below, and if you're feeling bold, tell us. Would you ever try a therapy based on restoring your microbiome? Kudos to you for being the kind of person who stays curious. That kind of mindset is what pushes science and society forward. Cellular and gene expression changes. On a deeper level, when they looked at gene expression in the intestinal tissues and immune cells, they found patterns that looked younger in the treated mice. For example, they looked at intestinal epithelial cells, the cells lining the gut, and measured something called a mesenchymal score. Higher scores mean the cells have shifted to a more aged, fibrotic state. The treated mice had lower mesenchymal scores in those gut lining cells, meaning the gut cells stayed in a more youthful regenerative state. They also saw differences in signaling interactions between cells. Overall, it was as if at the cellular level, the clock was turned back a bit in the gut and immune system of these mice. In summary, the old mice that got young microbiota were healthier. Their guts were more intact, their inflammation was lower, their microbiomes looked younger, with more longevity bacteria like Akkermansia, and they even moved a bit better. These improvements in Healthspan happened even though we can't yet say for sure if lifespan is extended. It's a big win for the idea of microbiome therapy.
That's really impressive. Improved gut barrier, less inflammation, better coordination. It's like these mice got a bit of their youth back, and all through gut bacteria.
It is impressive. This study provides some of the strongest evidence yet that the gut microbiome isn't just a passive passenger in aging, but an active player we might target to improve aging outcomes. As one longevity outlet summarized, continuous young microbiota transfer led to better coordination, a tightened intestinal barrier, reduced inflammation, and other rejuvenated markers, indicating microbiota transfer is a promising avenue for healthspan extension, pending further optimization and testing. It's like giving the old mice a microbial makeover.
Can we dig a little deeper into how the microbiome has these effects? Why does changing gut bacteria end up affecting things like inflammation or even coordination?
Great question. It comes down to the gut's central role in the body. The gut is not just a food digestion tube, it's intimately connected to the immune system, metabolism, and even the nervous system. About 70% of the immune cells in the body are located around the gut, constantly sampling what comes through. If the gut barrier becomes leaky, which often happens with age or poor diet, bacteria or their components, like endotoxins, escape the intestines and enter the bloodstream. This is like if the city's sewage system broke and waste started leaking into the city streets. The city's police immune system would be on constant high alert. The result is chronic inflammation everywhere. This inflammaging contributes to problems like insulin resistance, joint pain, even cognitive decline. That 2022 study we mentioned showed that an old microbiome leaking stuff can activate immune cells in the brain, microglia, contributing to brain inflammation and even signs of neurodegeneration in the eyes. Now, the microbiome also produces a lot of metabolites, small molecules like short-chain fatty acids, vitamins, neurotransmitters, which travel through our bloodstream. These can have beneficial or harmful effects. For instance, good gut bacteria make butyrate, an anti-inflammatory fatty acid that nourishes our gut lining. Bad ones might produce toxins or excess bile acids that cause trouble. In the aging context, the balance of these metabolites shifts. The 2022 research found changes in lipid and vitamin metabolism in mice with old versus young microbiomes. So installing a young microbiome is like fixing the factory. You start getting good products, metabolites, and less of the bad. And let's not forget the gut-brain connection. The vagus nerve directly links the gut to the brain, and microbial metabolites can also signal the brain. Some gut bacteria produce neurotransmitters or precursors to serotonin, dopamine, and so on. It's complex, but essentially a healthier microbiome leads to a healthier gut environment, which leads to less systemic stress and more balanced signaling to other organs. Using our metaphors, if the gut is a city, a youthful microbiome is like a well-functioning infrastructure with clean streets and good public services. The whole country, that is your body, benefits. If the gut microbiome is an orchestra, a youthful microbiome means every instrument is playing the right notes. The music of health stays pleasant. When the gut microbes fall into disarray with aging, it's like some musicians start playing off-key, throwing off the whole performance. By bringing in young microbes, we're getting those instruments back in tune. So that's why we saw those improvements. A fortified gut barrier means no more leaks, which means the immune system isn't overreacting all the time. Lower inflammation can lead to better muscle function and coordination because chronic inflammation can weaken muscles and nerves. A balanced microbial community produces helpful nutrients that keep metabolism on track. It's all interconnected. The gut is a hub for maintaining the body's equilibrium.
This makes me wonder, Could we do this in humans? Like, could we take a young person's gut microbiome and transplant it into an older person to rejuvenate them? It sounds like science fiction, but so did a lot of things once.
You're not alone in that thought. The findings open up big possibilities for human health, but there are important caveats. Mice are not humans, and our lifespans and complexities are quite different. What works in a mouse over a year or two might not be as effective or practical over decades in a person. That said, the concept of microbiome-based rejuvenation is definitely on the table now. In fact, even before this mouse study, there was curiosity about using FMT or similar approaches for age-related conditions. There are some anecdotal cases and small studies examining FMT in conditions associated with aging, like Parkinson's disease, for example, or metabolic syndrome. But doing FMT in generally healthy older adults to slow aging, that's uncharted territory. We'd need clinical trials to test safety and efficacy. The good news is, scientists are gearing up for that. The Quadram Institute in the UK has established a whole microbiota replacement therapy unit to facilitate such trials. They're likely inspired by results like Parker's, which showed so much cross-organ benefit in mice.
What are the challenges in translating this to humans?
Several challenges, both scientific and ethical. Safety. FMT in humans is generally considered safe when done properly. It's approved for severe C. diff infections, but there's always a risk of transferring something unwanted, like a pathogen or an imbalance that could cause problems. Each person's microbiome is unique, and introducing a new one could have unpredictable effects. In mice, they used antibiotics to clear the native microbiome each time. We can't give people antibiotics continuously without serious side effects like resistance or gut lining damage. We'd need a different strategy or very careful intermittent use. Efficacy. Maybe a young microbiome helps a mouse, but humans live much longer. Would we need continuous transplants? Perhaps we do periodic FMTs, or more likely, find a way to mimic FMT with probiotics or diet. For example, if we identify that certain bacterial strains, like Akkermansia or others, are key to the anti-aging effect, we might try to develop a probiotic cocktail or a pill that contains those, rather than doing full FMT, or encourage their growth with prebiotic fibers. Interestingly, in the progeroid mouse study, just giving Akkermansia bacteria was enough to improve Healthspan. Maybe for humans, we could boost our own good bugs through nutrition or targeted supplements, a less invasive approach than FMT. Ethical and practical issues. There's a definite yuck factor to fecal transplants. Not everyone will be lining up to take capsules of someone else's stool or undergo a transplant via colonoscopy, especially not as a preventive measure. We'd have to ensure donors are thoroughly screened to avoid disease transmission. If the idea took off, you might imagine young donors becoming a valuable resource, even leading to ethical questions like, should young people be compensated for donating stool to older people? Could this create inequities or exploitation? It's analogous to blood or organ donation, but with stool. We'd need protocols for fairness and safety. Regulation. Right now, FMT is only officially approved for certain infections. Using it as an anti-aging intervention would be new territory for regulators like the FDA. They'd likely treat it like a biological therapy that needs rigorous testing, scientific unknowns. We still don't know which components of a young microbiome are most important. Is it one or two keystone species that drive the benefits, or the whole community working in concert? If an older person has an aged microbiome, would it stay changed after a transplant or revert back without continuous dosing? These are questions scientists will need to answer. Despite these challenges, the implications are huge. If we can prove this works in humans, we could have a new way to address aging and age-related diseases by literally tuning up the microbiome. It might be less invasive than many drugs. Imagine treating someone with tailored probiotics or an occasional microbiome infusion to bolster their health span, but we have to do it carefully. As one scientist put it, results in animals are exciting, but we have to be cautious about extrapolating to humans until we have clinical data.
It's a lot to think about. I can see people being both excited and a bit hesitant about a fecal transplant for longevity idea. The ethical questions are real, but it's fascinating that something as humble as gut bacteria could play a role in something as profound as aging.
Absolutely. We're really at the early days of understanding this. Just a decade or two ago, the microbiome's importance was only starting to be appreciated. Now we know the gut microbiota are masters of our development and physiology, and we're uncovering their role in aging. The future might involve not just extending lifespan, but extending health span, keeping people healthier in their later years by manipulating the microbiome. It's almost poetic. The fountain of youth might be brewing in our gut this whole time.
So, to recap, scientists took older mice and gave them repeated transplants of gut microbes from young mice. The result was that these old mice showed signs of rejuvenation. Their guts were less leaky, their inflammation went down, their metabolism and even coordination improved. There was even a hint that they might live longer, though that part needs more testing. This all underscores how important the gut microbiome is to aging and health.
Exactly. It's a breakthrough in showing we might be able to slow aspects of aging by targeting the microbiome. While we can't jump directly to using this in humans without more research, it opens the door to new therapies. The gut isn't just about digestion, it's tied to immunity, brain health, and beyond. By keeping our gut microbiome healthy, or one day therapeutically rejuvenating it, we could address the systemic issues of aging, like chronic inflammation and declining tissue function. This is a promising step toward interventions that could improve quality of life for the elderly. As the saying goes, you are what you eat. And it turns out you might also be what your microbes eat and do.
I'm excited to see where this research goes. Maybe one day we'll have a routine treatment to refresh an aging microbiome. It gives a whole new meaning to the term gut feeling about staying young.
Ha! True. In the meantime, there are things people can do to nurture their microbiome, like eating a high-fiber diet, fermented foods, etc. But that's a conversation for another day. For now, this study is a proof of concept that microbiome rejuvenation is real in animals. We'll be eagerly awaiting clinical trials to see if it holds true in humans.
Thanks for breaking this down, Professor. It's like a glimpse into the future of geriatric medicine. Who would have thought gut bugs could be part of an anti-aging strategy?
My pleasure. Science is full of surprises like that. And to our viewers, if you found this as fascinating as we did, please hit the like button and subscribe to our channel for more deep dives into cutting-edge research. We love exploring how science can help us all live healthier, longer lives.
Also, let us know in the comments. Would you consider a fecal transplant or a probiotic therapy to stay younger if science showed it works? Or do you find the idea too icky? We're curious about your thoughts.
Yes, definitely share your thoughts. The field of longevity is evolving fast, and discussions help us understand public perception. Thank you for watching and staying curious. Until next time, remember, big breakthroughs sometimes come from the most unexpected places, even from the tiny microbes in our gut. Stay healthy and keep exploring.